Hi students, in this lecture we are going to learn Doppler effect. Let us see what is it. Let us consider a car is at rest. This is a car which is at rest, and here is a person and he is also at rest. Here is a person. See, when car gives a horn, frequency of the car horn is take it as F naught. F naught is frequency of the car horn. When car is not moving and person not moving, then frequency of a sound observed by the person is also equal to F naught. I am repeating, car is not moving, person also not moving. In that case, frequency of the sound observed by the person is again equal to F naught. Okay, this is the original frequency. But when car moves towards a person, or listener moves towards the car or away from car, means if there is a relative motion along the line joining car and person, if there is a relative motion along the line joining car and person, then frequency observed by the person will be different from the actual frequency. That means the frequency observed by him will be different from F naught. This is what we call Doppler effect. I am repeating. If car and person both are not moving, frequency observed by the person is same as original frequency. But if car is moving or person moving or both are moving, if there is a relative motion along the line joining them, if there is a relative motion along the line joining them, then frequency observed by the person is different from the original frequency. This is what we call Doppler effect. Okay. So here car is now source. Source in the sense which is now producing sound. And the person is now listener. Okay. Let us see how to calculate now frequency observed by the person. Let us take case 1. Let us take source is moving with a velocity Vs. We are taking this is velocity with respect to medium. So here medium is air. Sound is now propagating in air. So medium is air. So we are taking all velocities with respect to medium. So Vs is now velocity of a source with respect to air medium. And listener stationary. Listener stationary. Right. So coming to original frequency, let us take V. V is velocity of sound. V is velocity of sound. Okay. Then wavelength. Wavelength will be, let us take it as lambda naught. Lambda naught wavelength is equal to, it is equal to V by F naught. So take it as one. See, wavelength depends on motion of a source. So when source not moving, wavelength is equal to V by F naught, where V is velocity of a sound in air and F naught is original frequency. Okay, right. Now see carefully. When source is moving towards listener, see what will be the wavelength. We are knowing wavelength means it is the distance moved by wave in one time period, right? So here frequency f naught means time period will be 1 by f naught, reciprocal of frequency. Now see what happens. I am calculating now distance moved by wave with respect to source. So with respect to source, velocity of sound will be, so I am writing here lambda equal to velocity of sound with respect to source. Now sound is propagating towards the listener, right? With a velocity v, and source also moving towards listener. So with respect to source, velocity of sound is, it is v minus vs. So lambda equal to v by f. That is now f naught. So this is now wavelength of the wave in front of the source. I am repeating. This is a wavelength of the wave in front of the source. Okay. Once we are getting lambda, now we can calculate frequency observed by the person. See how much? Frequency f equal to v into lambda. V means velocity of sound with respect to him. Since he is stationary, velocity of sound is equal to v. So v into lambda. Lambda value, sorry, f equal to v by lambda, right? V by lambda. Lambda value v minus vs by f naught. So this is now frequency observed by the listener. This is what we are calling as apparent frequency, right? So here what we are doing is whenever source moves, wavelength changes, and that wavelength equal to V by F, right? V means we are taking here velocity of wave with respect to source. Therefore, it is V minus Vs into time. Time is now 1 by F naught. Okay, so into 1 by F naught. So this is now wavelength of the wave in front of the source, right? Now frequency observed by listener. So now he is taking f equal to v by lambda. So v means velocity of sound with respect to him. Now since he is stationary, with respect to him velocity of sound is nothing but v. So it is v by lambda. Lambda value v minus vs into f naught. Okay. Suppose source is moving away from listener. I am writing here. If a source is moving away from listener with a velocity vs, and sound propagates now towards listener with a velocity v, and listener not moving. Okay. Right. Now see what is wavelength of the wave behind the source. Remember, this is now behind the source and this is in front of source. We are focusing wavelength of the wave behind the source because this sound is reaching listener. Okay. Right. Now see what is wavelength. Lambda equal to V by F. But here velocity of sound with respect to source is V plus Vs with respect to source. Okay, V by F. F is now F naught, right? Because with respect to source. So no change in frequency, right? So this is now lambda value. Now frequency absorbed by him. F equal to V by lambda. Lambda is V plus Vs into F naught. Okay. That means if you want to generalize, what we can do is this frequency taken as F equal to V by V plus or minus Vs into F naught. So we are taking minus when source moves towards listener. Okay. When source moves towards listener, we can see when source is moving towards listener, frequency is more. Listener observes more frequency. More means when denominator is less, frequency will be more, right? And we are taking plus when source moves away from listener. Okay. So this is a case one. F equal to V by V plus or minus Vs into F naught, right? So here one key point is wavelength changes when source moves. Okay, right. Now see nodes correspond to this for case one. Yeah, first see definition part. What is the Doppler effect? The frequency of a source observed by an observer is different from the actual frequency due to a relative motion along the line joining them. This is called a Doppler effect. The observed frequency is called apparent frequency. Okay, right. See here notations what we are using throughout this concept. F naught, original frequency. F is apparent frequency or observed frequency. Lambda naught, original wavelength. Its meaning is when source not moving. I am repeating. This is original wavelength. That means when source not moving. Lambda, wavelength observed. Okay. Next, V, velocity of a sound with respect to medium. If you are taking now in this case, it is air. So it is air medium. Or if it is in liquid medium, we have to take liquid. Okay. Right. V suffix L, velocity of listener with respect to medium. And Vs, velocity of a source with respect to medium. So these are the notations we are going to use throughout this concept. Okay, right. Now see case one. Source moving and listener stationary. So original lambda V by F naught. Source moves towards the listener, then wavelength of the wave in front of the source. Lambda equal to velocity of a sound with respect to source V minus Vs by F naught. Now F equal to V by lambda, where V is velocity of a sound. Okay. And with respect to him, remains the same because a person not moving. Therefore, with respect to medium, with respect to person, both are same. So V by lambda in the place of lambda, V minus Vs by F naught. This is now expression. So this is expression when source moves towards listener. If source moves away from listener, it becomes V by V plus Vs into F naught. Okay, right. Let us now focus case 2. That is source is at rest, listener moves. See how we are doing that. So source is at rest, listener moving. Right. See where change comes. Source not moving. That means Vs equal to 0. Listener moves. Right. Suppose he is moving towards source with a velocity VL. Right. So we have notations like lambda naught equal to, it is V by F naught. And we discussed that wavelength depends only on motion of a source. Here source is not moving, therefore wavelength does not change. Right? Now coming to listener writing equation V equal to F lambda. Who is writing? Listener writing equation V equal to F lambda. Therefore, For listener, V is velocity of a sound with respect to him. So with respect to him, velocity of sound will be V plus VL. Sorry, yes, it is V plus VL. With respect to listener, velocity of a sound is V plus VL because he is moving towards the source and sound is coming from source towards listener like this with a velocity. So with respect to him, speed of sound is V plus VL. So that velocity equal to F lambda. Lambda is known. Therefore, F equal to V plus VL by lambda. Lambda is now no change in wavelength. It remains same. Therefore, lambda means lambda naught. That is V by F naught. Okay. Suppose listener moves away from source. Source not moving. Listener moves away from source. See where change comes. Velocity of a sound with respect to him becomes V minus VL, right? That is equal to F into lambda. That implies F equal to, it is V minus VL by lambda is lambda naught. That is V by F naught, right? That means here what is changing means velocity of a sound is changing because a person is moving. We are taking V equal to F lambda. So with respect to him, velocity of sound, right? So because of motion of listener, there is no change in wavelength. Okay. That means if you want to generalize what we can write, F equal to V plus R minus VL by V into F naught. If listener moves towards the source, taking plus because he observes more frequency. If listener moves away from source, he observes less frequency. So we have to take V minus VL. This is now case 2. See notes once for this. Right. Source is at rest, listener moving. So lambda, no change in that. If listener moves towards the source, this is velocity of a sound with respect to listener. Okay, so V plus VL. Then V plus VL by V into F naught. If listener moves away from source, if listener moves away from source, then with respect to him, velocity of sound V minus VL, that is equal to F into lambda. Then F value V minus VL by V into F naught. Okay, this is case 2. Now see case 3. Both source and listener are moving. See how we are solving this when both are moving. Case 3. When source is moving, wavelength changes. Listener also moving. Okay. When source moves, wavelength becomes lambda equal to, it is lambda equal to V by, it is V by F, V value, V plus R minus Vs by F naught. If source moves towards listener, it becomes V minus Vs. If a source moves away from listener, it becomes V plus Vs. Okay, general case. Next, when listener moves, velocity of sound becomes V plus R minus VL. That is equal to F into lambda. V plus or minus VL. When listener moves towards source, it is V plus VL. If listener moves away from source, it is V minus VL. Okay. Now substitute in the place of lambda this value. Then see what we get F value. Then F value V plus or minus VL by V plus or minus Vs into F naught. So this is the result we are going to use in each and every problem. In each and every problem. Okay. F equal to V plus or minus VL by V plus or minus Vs into F naught. F is known as apparent frequency and F naught is original frequency. Right. So here we are taking all velocities with respect to medium. Right. Now, suppose source is moving. Let us say source is moving like this at some angle theta with a velocity vs. So we are saying in definition part, it is because of relative motion along the line joining them, right? That means velocity component of the source along the line joining them is Vs cos theta. That means in the place of Vs, we have to write Vs cos theta. Okay. In the same way, suppose if listener moves, suppose like this, suppose angle is alpha. Then we take his velocity along the line joining them. That is VL cos alpha. So in this place we are going to take it is VL cos alpha. Okay. That means we have to always focus velocity components along the line joining them. I am repeating. We have to always focus velocity components along the line joining them. Right? Let us see carefully how we apply now this result. Suppose you are given question like this. Source moving towards listener. Listener moves away from source. Source moves towards listener. Listener moves away from source. Okay. So first focus like this. If only source moving, what happens to frequency? If only source moves. When source moves towards listener, only source, then listener observes more frequency. Okay. And this Vs is coming in denominator, right? Then to make F value more, we have to make denominator is less. That means that is less when we take V plus Vs. Wait. I'm making mistake here. It is moving towards listener, right? Towards listener means listener observes more frequency. To make F value more, denominator must be less, right? To make F value more, denominator must be less. This is less when we are taking V minus Vs. Okay, right. Next, when listener moves away from source, if you take only listener moves away from source, then frequency must decrease. And that happens when numerator is less. When numerator is less. That means in this case, F becomes V minus VL by it is V minus Vs. Okay. When both are moving, sorry, listener moves away from source, and source moves towards him. I am repeating. When source moves towards listener, frequency must be more. To make it more, denominator must be less. And that is less when we take V minus Vs. When listener moves away from source, frequency has to decrease. That means we have to make a numerator must be less. That happens when it is V minus VL. Right? Okay. Suppose take like this. Source moves towards listener. Listener also moves towards the source. Then see what happens. Frequency. Since the source moving towards listener, source moves towards listener, frequency must be more. And this is more when denominator is less. Denominator is less means it must be V minus Vs. It is less. Listener moves towards the source, then frequency must be more. It is more when the numerator is more, right? So it is V plus VL. So when both are moving towards each other, okay? Let us take one more case like that is source moving away from listener, listener also moving away from source, right? Now, only because of source, since source moving away from listener, frequency has to decrease. It has to decrease means denominator must be more. That means we have to write it is V plus Vs. We are making denominator is more, right? Now listener moves away from source. Listener moves away from source means he should get less frequency. So frequency will be less if numerator is less. That means we have to write V minus VL. Like this, in all cases, we can write frequencies. Okay.